Welcome back to this series of videos on area and perimeter. This is the second video on triangle, and we are going to continue with our derivation. But before we start that, we take a quick recap of what we did in the previous video. In the previous video, we looked at two formulas. One is area is half b into h, and area is the square root of this entity. This is the Heron's formula you have here. And both these apply to all the three types of triangle, or any type of triangle, right? So you have a right angle triangle where the A and H are same because this is right angled. And then you have the other types of triangle wherein you have acute angle triangle where your angle is less than 90 degrees, or all the angles are less than 90 degrees, and obtuse angle where one of the angle is greater than 90 degrees. So it's valid, these equations are valid even in obtuse angle triangle, right? Now let's look at two special triangles. One is isosceles and equilateral. In isosceles you have two sides equal, and equilateral you have all three sides equal. That's one of the properties. And the second property which is common to both isosceles and equilateral is where if you draw a median is a line from the vertex and that bisects the other side. So if you choose a median from the vertex where the same sides meet in isosceles, that's this vertex, then this median will be perpendicular to the base, and also it equally bisects the angle. So these two angles are same. This is true in equilateral triangle as well. So you'll study more about this in your geometry, but let's assume that we know this, and with this knowledge, let's try to find out the area of isosceles triangle and equilateral triangle. So to start with, let's start with isosceles. So in an isosceles triangle, let's first label the triangle. So let's label them as A, B, C, D. One of the first thing you do always is to label your triangles so you can communicate better. And then we say, hey, we know that this is the median is perpendicular, and the median is something that bisects your opposite sides. Now we can say in triangle ADC, which is a right angle triangle, which is a right angled triangle, we can say that h squared plus b by 2 the whole square is equal to the hypotenuse, right? Some of the Pythagoras theorem, you use the Pythagoras theorem, or in other words, you can say that your h is given by a squared minus b squared by 4, or 4a squared minus b squared by, h squared here, yes, by 4, or your h is given by square root of 4a squared minus b squared divided by 2. Of course, this you can further simplify it, and you can say this is equal to square root of 2a plus b into 2a minus b, but that's something I leave it to you. You can keep your equation of h to here, right? Once you do that, the area of the triangle ABC would be equal to half base into height, and you know that height is you have represented height as a function of the other two sides, A and B. So that's half of b into square root of 4a squared minus b squared divided by 2. So we substitute for h as it is here. Once we do that, yeah, so that's it. So that's your you can further simplify. You can say b by 4 square root of 4a squared minus b squared. So that's your area of isosceles triangle. Now you can substitute. When you come to equilateral triangle, you can actually take this. Now equilateral triangle is also an isosceles triangle. Just the fact that this side is your b is equal to a. So that's all the difference is between an isosceles and equilateral triangle. So you can substitute that and you can find the area of equilateral triangle. Area of equilateral triangle, you can pick up the isosceles triangle, and instead of b by 4 of square root of 4a squared minus b squared, you can substitute a, and that would be a by 4 square root of 4a squared minus a squared, because b equal to a, because this is a symbol for because. Or you can say you have a by 4 into square root of 3a squared. This becomes root 3 by 4, and this a squared comes out, and if you multiply with a, this becomes root 3 by 4 a squared. So this is the area of your equilateral triangle, which you can form as a corollary for your isosceles triangle. Now alternatively, we can also use Heron's formulae, and let's apply Heron's formulae for equilateral triangle. So you have S is given by a plus b plus c by 2. So that will be a plus a divided by 2. That is equal to 3a by 2. And an area of triangle would be square root of s into s minus a into s minus b into s minus c. So that will make it square root of 3a by 2, 3a by 2 minus a into 3a by 2 minus a into 3a by 2 minus a. Okay, so this is part of your entire square, right? So don't think this is minus sign. So this is all, you're multiplying all of this inside the square. Okay, so what you have is this will reduce to the following: square root of 3a by 2, square root of 3a by 2 into a by 2. 3a by 2 minus a is a by 2 into a by 2 into a by 2. So you have basically 4a by 2. You have 4a by 2. So you can take two of them outside, and you can say that this is equal to square root of 3, and in the bottom you can take 4 into 4. So square root of 4 into 4 is 4. And in the top you can see there is 1a, 2a, 3a, 4a. So into square root of a power 4. So that is square root of 3 by 4 into a squared. So that is the area of equilateral triangle. We found it using Heron's formulae, and we also found it using as an extension of your isosceles triangle, using your half BH equation from where we started, right? So you can use either of the approaches, and it'll lead you to the same answer. So here's a summary. Equilateral triangle area would be root 3 by 4 a squared, and isosceles triangle would be b by 4. The b is the side which is not equal, into square root of 4a squared minus b squared. I hope you enjoy this video. In the next video we will do some problems, numerical problems with real numbers. See you then. Bye.